Saxon Algebra 1/2, Lesson 19. Students, today we're going to talk about multiplying and dividing fractions. This is a review. I know you've handled this before, but we're going to just freshen up your brains and remind you of how it works. The glorious news is that compared to adding and subtracting fractions, where we have to make the denominators match, this multiplying and dividing, this is a breeze. It's so much easier. It's so much more fun and relaxing. It looks like this. We say 4/9 times 5/7. Remember that the dot means multiplication, but we can also use parentheses. We are really getting away from using x's for multiplication because in algebra that's just confusing. What we do in the simplest cases like this one, we just multiply straight across the top. 4 times 5 is 20. And straight across the bottom, 63. There's our answer. We can't reduce. Yay! That's all there is to it. Here's one that's just a slightly confusing notation at the first. This says 2/3 to the third power. That's a little weird. But then we remember, okay, the way this works is that this is the base, this is the exponent. The exponent tells us how many times to multiply the base by itself. So this would be equal to 2/3 once, 2/3 twice, 2/3 times itself 3 times. This is the same. Now we can easily say, oh, 2 times 2 is 4, times 2 more is 8. 3 times 3 is 9, times 3 is 27. So there's our final answer. Cool, right? Oh, that's a terrible box. I can multiply fractions, but ask me to draw a box and things go wrong. 8/27, that's correct. And here's one more that illustrates a fun part of multiplying by fractions. 4/9 times 18/30. Now, it's perfectly fine if we just multiply across the top, multiply across the bottom, and then look to see if we can reduce it. Here we couldn't reduce it. Here we couldn't reduce it. But when I see a fraction like this, I always think, and you know, these other ones too, I always think, let's look and see if we can cancel. Cancel is the technically correct name for this, where we look for factors in common between anything in the top and anything in the bottom. Remember, the reason that we do this is because if we can reduce our numbers before we multiply instead of after, it makes our job much easier. That's one of my algebra rules of thumb, is always make the numbers smaller before you make them bigger, if you can, right? But we always look to make them smaller. So that's what we're doing here. We're going to try and make these smaller, and here's the way my brain goes about it. I see 18 on the top and I see 9 on the bottom. They happen to be in opposite fractions. They could be in the same one. That's fine. What's important though is that we can only reduce when we have one number in the top, one number in the bottom. And what we're doing is we're saying we're going to divide this set of factors by 9 because 9 goes into 18. That's the number I like. We're going to divide the top by 9 and the bottom by 9 and make our numbers smaller. If we divide both top and bottom by 9, 9/9 is equal to 1, and we're still in balance. The way that I show this is that 18 divided by 9 is 2, 9 divided by 9 is 1. Remember this? This is fun, right? Now I see, oh, look, 2 will go into 30. It goes in 15 times, right? I recognize that right away because these are both even numbers. So I could say, okay, let's divide them both by 2. 2 divided by 2 is 1. 15, I gave you the answer. 30 divided by 2 is 15. Okay? Now I'm going to go through and circle what I've got because I've got so much crossing out, it gets confusing. All right, so there's what I'm left with. 4 times 1 on the top, 1 times 15. Obviously, if I have ones, I can't cancel anymore. So I'm just looking one more time. Is there any number that goes into both 4 and 15? Any factor? And I think, no. This is 2 times 2. This is 3 times 5. There's nothing in common. So I'm done, and I write my final answer, 4/15. We're going to get lots and lots of practice doing problems like that. And so you'll have lots of time to work on your strategies. But this is fun, I think, looking for the patterns in the numbers and canceling them. Okay, that is our talk about multiplying fractions. Dividing fractions is just as easy, it just has a slight twist. Here is an example of a problem we might see. Okay, now remember, first I'm going to tell you the very practical steps we follow to do this, and then I'm going to talk just a little bit about the theory behind it. As you advance in your studies, I will be able to explain this more and more to you, and you'll see it more and more. But for now, I really need you to take on faith that this makes sense. When we are dividing by a fraction, what we do is we copy the first number exactly the way it is. We flip that division sign into multiplication, and then we flip the second fraction upside down. Okay? Change the division into multiplication, change the number after the division sign, flip the fraction upside down. Okay? Just trust me, that's how we do it. Now we can cancel before we multiply, if that's possible. Reduce. 27 is a prime number, so I don't think that's going to reduce at all. And knowing your primes and knowing your being able to do a prime factor tree in your head helps a lot in this stage. 4 and 6, though, I can make that work. I could take 2 out of both of those. Or I also see, oh look, I could take 3 out of both of these. Because 3 times 6, or 3 times 2 is 6, 3 times 7 is 21. So I'm going to do that. I'm going to take the bigger number out. I'm going to take 3 out of both of these. This will be 2. 6 divided by 3 is 2. 21 divided by 3 is 7. All right, I like that. But look, now I still can do this one where I can divide both by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Time to circle. This one's down to 1, so I know it's done. 27, I said, was prime, so that's done. So now I just multiply. Across the top is 14, and across the bottom is 27. And that's our final answer. Yay, it's done. We got it right. All right. The last thing I'm going to do is talk to you very briefly about the theory behind this, and this is the best way I can explain it. Let's take the number 8. And we want to divide it by 2. Well, now you all know in your heads, 8 divided by 2 equals 4. We know that. That's a no-brainer, right? Especially if you're from a family of 4 and there's 8 pork chops for you to share with your siblings. Your parents have already eaten. You know you each get 2. But pretend that you didn't see that answer automatically and you decided, well, I'm going to treat these numbers as if they were fractions because we can make them fractions, right? And so the rule is take the first number, change the division into multiplication, and flip the second fraction. 8, 10, then let's just multiply it across. Let's not think about canceling yet. We get the very same answer. So we can see that dividing by 2 is exactly the same as multiplying by 1/2. And maybe that will fit into your brain and you can see, oh yeah, it does work if you change the sign and flip the number. It works in all cases. If this makes your head feel wobbly and you don't really know what I'm talking about, don't worry about it. Just memorize this process. Division goes to multiplication, second fraction flips. Remember that the first one stays the same. As we go on, like I said, we will do calculations that will help us understand this rule even better. And it will make more sense as we go, all right? So for now, just remember how we go about it, and trust me, it always, always, always works. Lesson 19 is over. Thank you, goodbye.